Well, it's basically, it was virtually impossible for me to hold the camera and show you some readings from it. But basically, you had power coming in. This is the battery, and that went to the board on the front, and that one went to the controls, which I tested out, and the buttons worked, the accelerator and the rear brake. And then these two were unpopulated, so that's the brains, as it were. So we know we've got voltage in, we know the battery is charging. This is the motor. So let's see if we can find anything wrong. So obviously I'll zoom in. I've got the microscope ready because I am going to need it. But let's see what we can see through the camera first of all. That should be enough. So we'll pop this open. I assume this just opened somehow. There you go. There's a big heat sink on the rear of this. Lovely. That's it there. Right, let's pop this board out. Can't see anything. Oh, what's that? Let's pop this board out and we'll have a little look inside. Even with my naked eye, my bad eyes, I can see something there. It looks like an ant. So let's get this under the microscope. And 2 seconds, let me just pause and get it in. Right, so under the microscope, and we have 6 chips there. DH045N04D. They look the same. I can't see the writing on all of them, but they do look the same anyway. Quick look through this board. See if I see anything blown. Oh, we've got test points there. A chip, transistor of sorts, the resistors. Let's see what that ant was. And it is. Oh, there's that little fly. See if I can zoom down a bit. That's as close as I can get. What is that? I'm not sure what it is. Is that a spider? Is that an ant? I don't know, but it definitely shouldn't be in there. Poor little fella. It doesn't look like he shorted anything out. And if he was, that cap and the bigger cap are on the same pad. Let's see him around the other side. Yeah, he's not shorting anything. We'll get rid of him. We don't need him. I use some old tweezers. Be gentle, even though he's dead. Not sure what he was. He was there anyway. I'll put him on the side. Have a little funeral later. So let's go over this board. Right, so another look over this board, and it worked out that looking at it this way round, pin 1 and 2 were basically black and white, so we've got ground, and it grounds the white pin to turn it on. So trace that track all the way up to the top into that chip there, I believe that's an op amp, and it all seemed to meter out fine. There's a ULN 2003A. I think that's a high voltage regulator, isn't it? A step down. It's gold. So anyway, we'll look through these. Tested the coil, tested that cap, tested all the components where that little fella was. I thought I'd better check the back again, because I quickly went over these transistor MOSFETs, whatever they I didn't look them up, and then all of a sudden I looked at this closely to see a number on it. Can you see a hole in it? Right, if I put it onto the vise, it will hold it steady, hopefully. Right, let me get zoomed in. There. Is that a hole? Let me get my tweezers. So before I do anything, because I'm going to scratch it, STM 32G, and then we got 030K something T6 K8. Oh, there we go. Right. Can't remember what the lens. Oh, it's a polarization lens, so I can't see it. So, oh, right. So that looks, yeah, 0. It's not a D, is it? So 030K 8T6. I'm going to assume the rest is manufacturer stuff, but GQ 2159R CHN China 0521K, and it's more that there. Right, this is coating. It could well be coating. Let me turn the polarization off. If I can get some IPA. Let's just see if it does clean. No, is that just where I scratched it? Just a second ago. Oh, it could just be gunk. Oh, that's alright. I thought I'd found the fault. Sorry about the noise. Neighbour's doing some work in his garden. Oh, this actually looks okay now. Right, so well, I didn't jump to conclusions and buy one. So I've still got to somehow take all the other boards out of the that scooter. If not, I'm filming on the floor. I thought I'd found it, but I haven't. So I'm going to continue looking. So it must go to one of these chips. Right, I was just testing around the board. Went to measure this little diode. I noticed how loose it was. So I don't know what happened there. And this seems to be R negative. And when you press the switch, it puts the negative turn to here. And I was tracing it up. That's it here. And it goes up to this chip here. So I presume, well, it puts a negative to that one there. It obviously turns it on. So anyway, let's solder that back up. Tiny bit of flux. Little blob. Just the blobby. Oops. Well, this is definitely on there now anyway. Alright, let's give that a go. Right, I've been hunting around this board and I thought it's a couple of diodes, it lost the 20 volts. And to me it was something to do with these two buck converters. So to me, we've got our chip, coil or inductor rubber, and the caps. So that to me is a buck converter, and we've got our 20 volts comes in to here, then it will come out at 5.5 volts, then feeds into this one. We've got a smaller inductor, smaller other caps. So that to me now is another step down buck converter, so this will probably take it down to I think 1.8 volts. So I thought I'd set up the oscilloscope. I'll put it on auto. I'm going to inject 20 volts straight into where the battery would be. That's it on now. So on this 4AXA chip, the top center, sorry, pin 5, which is top middle, is the input pin. So if I do my scale, and you can see there 20.3 volts, 20.4 volts, and pin 4 will be the enable pin. So let's see if we can get a voltage onto that, and we don't. So if I short what is basically the button on the handlebars together, let's see if I can do that one-handedly. There we go, we've got 5.12 volts. Yep, 5.1 volts there. If I go back to that middle one, if easier to go on that cap, you see I've got 20 volts. Now so we've got our supply in, ground is the center one, that's our enable pin, and then this is our switch. So this should have a square wave, and there's nothing whatsoever coming out of it. I can go onto that pad there, you can see I've been poking around quite a bit, there's nothing coming out of this whatsoever. This is the bootstrap, we've got nothing, and the feedback is that pin there. Looks like we've got some noise on the feedback, and the bootstrap, no, even with the probes off. So back onto that, we double check we've still got our 5 volts, so it's very awkward and I don't want to short anything out. Yeah, 5.25 volts. We'll go straight onto that switch. I'm not sure if that's just interference or... See, that should be a square wave. So I think that chip's gone. See, that's interference from something. So it's not picking up there, but there's no output coming from this, so I think that chip's gone. So I'm going to order one of these up, and well, I've learnt quite a bit about buck converters. Well, I think I have anyway. Okay, I'll order one up and I'll continue a video hopefully in the next couple of weeks. Right, it's been several weeks later. I was messing around with that GBX 155 and I've had to order some chips, so let's get under the scope. Swap this 4AXA, that DC-DC buck converter. These are SOT 23 sixes. So the SOT 23 is the size, 6 being it's got 6 legs, so let's go under the scope. And that is her there. That's the one I want to change. So let's put the iron on. I should have put this on first. She uses, I think I just hit a little cap underneath there. Got to watch that. Alright. Move that little cap back into place if it was a cap. Where are we? And there I am. That's back into place. Go for that. I think we just need a bit of solder onto that pad down the bottom there. Okay. Right, so that's that DC-DC buck converter in. I'm ready to inject 20 volts. I'm only going to do half amp for 500 milliamps. Let's set this on auto. So we've basically got our live goes direct to one side of the cap. Our negative we're going into the plug of where the battery would go. So if I connect my probe to the same negative, there we go. Ouch, stabbed myself. So let's turn on the power supply. Okay, and then we know one side of this cap is 20 volts. You won't see it there, but you'll see that line jumping up. There's our 20 volts. So this is where we would have a square wave coming out, or some form of wave. Now these two pins at the end, right, it's 5 volts, but it's going to be drawn back down to 0, so I'm not going to get a shock. So what we're hoping for now, if that buck converter works, this is going to give me a square wave up here. Yes. So we can enlarge that. Right, so we've got our square wave, and then we've got, I don't know if that's the bleep as well. It's supposed to just be, you can see it better there. There we've got a sine wave, a square wave, and which looks like an AC wave as well. If I can make that smaller. But it's definitely working anyway. I'll put this in auto range. Put something at my front door there. Yeah, well, it's definitely working. So I'll get this back together. Let me turn the power off. We'll have a little scooter. Don't know what I'm going to do with it. I'll find some kid who might want it. Perfect. Yes, happy days. Right, that's that back together. Let's speed you through this. It's definitely working. See it there, hopefully it doesn't fly across the room. I think it just needs a little use, to be honest. Well, I'm sure it's going to make some little child very happy. I'll get a grip ball for it as well. Alright, excellent. Thanks for watching, and I'll do some more videos soon. Maybe ones you can see what I'm actually doing. Right, so this is the tiny component that made it all fail. It is the DC-DC buck converter, SOC 23 6 pin, so -6. So I've put it on a pound coin just to show you the size of this, because under the microscope it looks massive.